What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to calculate the pH change after we add 0.02 mole of NaOH to 1 liter of a buffer solution or a mixture containing 0.1 molar of propanoic acid HC3H5O2 and 0.1 molar of sodium propanoate or NaC3H5O2. In the other video, we already calculated the pH of the mixture of buffer solution containing 0.1 molar of acid and its salt. Let me show you. We had 0.1 and 0.1. Acid plus water is going to give me hydronium plus base. Initially we had 0.1 and 0.1. Change is going to be negative x and plus x plus x, and equilibrium is going to be 0.1 minus x plus x, 0.1 plus x, so Ka equals to x times 0.1 plus x divided by 0.1 minus x. X and x cancel out, 0.1 and 0.1 cancel out. X will be equal to 1.3 times 10 to the power of negative 5. So pH is going to be negative log of this number. So pH will be 4.89. So before addition of NaOH, the pH was 4.89. Now let's see what is going to happen when we add 0.02 moles of NaOH. So we have acid HC3H5O2 plus NaOH. Since it's a strong base, it dissociates completely into its ions and it's going to produce H2O plus C3H5O2 minus. So initially we have 0.1, 0.02, 0.1. So acid is going to neutralize this base. So we have 0.1 minus 0.02, 0.02 minus 0.02, 0.1 plus 0.02. So we have 0.08, 0.12. Then I can say acid plus water is going to produce the conjugate base and hydronium ion. So I'm going to have the ice table. After the reaction we have 0.08, approximately 0 for hydronium because it's 10 to the power of negative 7, and here it is 0.12. Negative x plus x plus x. So we have 0.08 minus x, 0.12 plus x, and x. So Ka, dissociation constant, is 1.3 times 10 to the power of negative 5 equals to 0.12 plus x times x divided by 0.08 minus x. So if I neglect x comparing to 0.12 and 0.08, this cancel out, and I'm gonna say x equals to 0.08 times 1.3 times 10 to the power of negative 5 divided by 0.12. So x will be 8.67 times 10 to the power of negative 6. So pH will be negative log 8.67 times 10 to the power of negative 6. That will be 5.06, or 5.06. So pH is going to change from 4.89 to 5.06. As you see here, the pH change is going to be very, very insignificant. It's not really significantly changed. Why? Because we're adding the base to the buffer solution. Since we're adding it to the buffer solution, and we know buffer solutions are resistant to pH change when we add acid or base. So that's why the pH change before and after is going to be, it's not going to be a much. I hope you enjoyed this video. Please leave me a comment if you have any question, and I'll get back to you as soon as possible. Thank you for watching and have a great day.